Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT, here from WX Risk in Central Virginia. Your commander of chaos, your colonel of confusion, your captain of catastrophe. Let's talk about the weather, which, by the way, happens to be one of my favorite topics, which is really fortunate because I'm a meteorologist. And we'll start out lots to talk about here. Just briefly, reminding you that there's the Facebook page, the email. If you want to reach me, two different emails there, and of course there's the new Twitter page and the Facebook page. This here is a new Twitter page in case you haven't seen it yet. It looks really good. There's a Bill Murray from the Groundhog, one of my favorites. You know where he says, "You want a forecast for the winter? I'll give you a forecast. It's gonna be long. It's gonna be dull. It's gonna be gray, and it's gonna last you for the rest of your life." Anyway, this here is the snowstorm page from the website itself. So there you go. In case you want to see that, I update that every couple of days now, especially with the pattern changing as it is. There'll be a new update tomorrow. And then let's get to our topics. Obviously, we're going to talk about the pattern change. It's beginning now. We'll talk about this Saturday and the Arctic air mass outbreak that's coming after the event and the end of the month potential. So let's get right to it. Now, this here is the jet stream pattern here. This was as of January 10th, a couple of days ago, but the overall pattern hasn't changed much. You can see what the problem has been. We've consistently have this, and this is since December 1st. We've had this ridge here over the northern Pacific and the Alaska area where that amazingly large pool of warm water is in the North Pacific, right in this area. That pool of warm waters would be about here on the map. So that's what's causing the ridge, to keeping the ridge locking in place. Then, of course, we have this trough here, and that produces this ridge here. Bada boom, bada bing, bada boom. That's what it's been for the past for about 45 days. And this is a great pattern if you live in the western United States, the upper plains. It looks great, but not if you're not if you like winter weather on the East Coast or the eastern third of the country, for that matter. Indeed, let's take a look at the temperatures over the last 2 weeks. Look at these anomalies. Late December into early January, obviously the coldest time of the year, or pretty much close to it. You can see the rainfall, the temperature anomalies. Look at those reds. That's +9 to +12 Fahrenheit above normal. Everybody essentially east of the Mississippi River. That's pretty damn impressive. And then the percentages of rainfall. Now it has been very wet. Again, generally east of the Mississippi River. A little dry right along the immediate coast, but large portions of the Great Lakes, the Ohio Valley, the Appalachians, the interior, the Deep South, Tennessee Valley have seen a tremendous amount of precipitation over the last 2 weeks. So some of these areas 300% above normal. Very impressive to say the least, and that's where the mean trough has been. We've had a lot of storms which have developed, and they've gone through this sort of track like this, in through up into, and that's what we've seen. That's warm here and rain here, but rain and snow throughout all that area, and we're going to see more of that. This is the overall jet stream pattern for the next 5 days. This is the mean and average. So we can see several important features here. First, let's point out there's our polar vortex. It's in Baffin Island and it's near Greenland, which is one of the reasons why the Arctic Oscillation here, as you can see, is still positive. And of course, the NAO is still positive. Okay, and we know that. Now, we do have this ridge building here into Alaska, so the EPO is now beginning to turn negative a little bit, so that's good news. And look at this enormous monster up below here, this trough. Now, if you want to, you can take a look at the forecast for the Pacific Northwest, British Columbia, Idaho, Washington State, Oregon. A lot of snow coming there over the next several days. Some big, pretty impressive snows, even down to the coastal areas in Seattle and Tacoma, Bellevue, what have you, Bellingham. A lot of snow there in the Pacific Northwest. And of course, if you have a trough here, over the western United States, you have to have a ridge here. So there we go. I mean, it's essentially, as you can see, almost the same pattern as this, which is from January 10th. But there are some changes happening. First, the ridge is being flattened a little bit here, and second, this feature here. You can see how it's beginning to bend this way. It's expanding in this direction. You see we're getting a ridge now forming here over northwest Canada, and that's going to act as a kicker and force this system to come eastward, and that's going to be the beginning of the pattern change. So this is what happens in the 6 to 10 day. Now that's a huge difference from this. Look at the difference. Okay, I mean, totally different pattern. So if anybody's telling you this is not a pattern change, the person telling you that is either an idiot or doesn't know what they're talking about, because that's what this is. So we have a very sustained strong ridge here very classic position along the west coast on the Rockies up into northwest Canada into the Arctic region. We have a big trough here in the eastern Pacific, and there's our polar vortex here. Still positive over the NAO and probably the Arctic Oscillation, but we do have a positive anomaly here in the heights and a trough here on the east coast. So we're getting cold air coming in this way, and there's a storm coming for the east coast. Now the problem is, of course, that since we're so warm, we have to get the pattern to cool off first, and that's going to take a while. All right, and then finally, this here is the 11 to 15 day. And you can see what this looks like. The pattern remains the same. Substantially big ridge here over the west coast, just like this, and then a big trough here. Our polar vortex is still strong, intense, and Baffin Island. So we still have a positive NAO, unfortunately. But we do have some positive heights here. So it may be going towards neutral. And if when we take a look at the teleconnections, we'll see that's exactly what happens here. Now, one of the features which is driving the pattern is, of course, the MJO, the Maddie and Julian oscillation. So this is the Australians, and this is important here because you see this? These are the Australians, and they started running again. This is January 9th, and you can see they run it out. They have a very good MJO model here, one of the best, and you can see that it comes in 4, 5 here, and it swings all the way out to 7 and then into 8 by the time you get to February. So that's really important. And this is the European model from today, and you can see here it's in phase 5. And before it was going into neutral circle down here in 6. Now see what it's doing? As it goes further out in time, it's always going to want to go to the neutral circle, regress to the mean. But in fact, as you go further out in time, the MJO is taking this further and further into phase 8 and phase 1. And that's important because that's where all the winter storminess is. Now, this is the MJO from the middle of October to today. And what you want to notice here is how the MJO was stuck in a cycle. You see down here, it was all stuck here in December in phase 1 and 2, which is not in phase 3, which are warm patterns for the eastern United States. So why was it stuck there? Well, one of the reasons it was stuck there was because of this. Now, this, as I've talked about before, this is the, and of course, this is connected to the fires and the drought in Australia. This is the positive Indian Ocean Dipole, IOD. And what it is pool. This is the Indian Ocean here, and you can see the cold water is here and the warm water is here, and that's why this is a positive IOD. Sometimes the cold water is here and the warm water is here, in which case it's a negative, but right now this is a positive IOD. And you can see this is from November 1st. See this graph, November 1, and you can see, look at the peak, 2.06, arguably the strongest IOD positive on record. That may have been back in November. And of course, that shut down the precipitation in Australia and in South America, and it played havoc with the MJO, because when the IOD is positive like this, the MJO always stays stuck in phase 1, 2, and 3. So that's what this is. This whole mishmash was connected to this. And this is just a schematic of what it looks like. You can see this is the Indian Ocean. There's the cold water in the east, and there's the warm water in the west, and that's exactly what we see there. There you go. So it worked out quite nicely. So, and if we go beyond this, this here, like I said, this is the Australians, and then this here is Kyle McRitchie's experimental MJO, and you can see that it goes all the way out into phase 8 and 1 and 2 as we go into the middle of February, which are all great stormy patterns. What does that typically look like in January and February? This is phase 8. You can see how cold it is in the eastern United States. It remains that way in phase 1. Another way of looking at it is to look at how the pattern evolves. So if we go back to, let's say, this image here. Now we're looking at phase 5. Let's look at where it is right now. So let's make sure you can see it. There is phase 5. You see it? And there's phase 4 going into phase 5. So what does that look like? Well, the folks of the Climate Prediction Center have this new way of looking at things, and let me show you what it looks like. Now this is the phase 5 when the MJO is very strong. And by the way, when the MJO is out here, okay, just in case you don't understand this, this is the neutral circle in here. See this? That's when the MJO is very weak. Over here is when it's strong. So anytime it's by the edge of the graph, over here, over here, over here, that's when it's strong. So you can see this thing is really strong. Same thing on this one. This is always strong on the edges on the MJO. That means it's a very strong impulse. So this thing is really strong. Okay. Now over time, it's going to weaken over time because the model is going to regress to the mean. That doesn't mean it's actually going to weaken like that. It's just the model is showing that. Okay. So let's go back to this chart here for a second. Now, what does this mean? This is phase 5. So let's take a look at this. At the start of the pattern, you can see there's a huge ridge over the eastern United States and a huge trough in western Canada. That's at phase 5. And that, folks, is that. It's the same thing. Amazing how this works out, isn't it? That's just stunning. Man, I love it when everything comes together like this. It is so cool. Okay, so that's phase 5. Now look what happens. This is 5 days later. This is 5 days later. This is 10 days. This is 15 days. This is 20 days. And by the time you get to day 25, you have a massive trough here over the eastern United States, and you have strong blocking here in Canada. You can see that. Also see it on day 20 as well, strong blocking. And if you take a look at this for day 6, you would see the same sort of thing. Okay, so here we can take a look at phase 6. Let me clear this out. And this is going to be phase 6. Oops, let me change that 1 second. There's phase 6, and you can see the same sort of thing. So the ridge is weakening here at the beginning of the period. This is day 5. This is right now. The ridge is weakening. This is 5 days, and this is 10 days. You can see the heights building here in Greenland, typically what happens. And then by the time you get to day 15 and day 20 and day 25, look at this. Monster negative anomaly off the coast, strong blocking here. Look at day 20. Big negative anomaly over the east coast of the mid-Atlantic, strong blocking in this sort of pattern. So this is where the pattern typically evolves to 20 days down the road. So this is January 13th, 20 days from now. Well, you do the math, we're talking the end of the month, which is why one of the reasons why I'm so bullish about the end of the month. All right, if we look at our teleconnections here, you can see that the PNA pattern here is clearly in the negative because of the huge trough of the western United States, but it does move up over time in the positive. The NAO is close to neutral. The Western Pacific Oscillation is also close to neutral, and the EPO begins to drop as the ridge begins to form over the west coast. The Arctic Oscillation over the past, since December 1st, except for 2 little brief intervals here where it went negative, for the most part we've had very strong positive spikes. So the Arctic Oscillation has been very strong, and to get it to come down, first we have to get it to neutral. So that's the first thing, and that's going to take some time as well. If we look at our teleconnections, our models here, now this is the European ensemble, and you can see that over time, even though it's strong positive now, by the time we get to January 20th, it is pretty close to neutral at this point. So that's a good sign. This is the North American oscillation. Again, very positive. Okay, it neutral here, slight bump, and then it goes a little negative here at the end of the month. So that may be a good sign. If we look at the West Coast, our patterns on the West Coast, there's the Eastern Pacific Oscillation, which is it's neutral, then positive, then neutral. So it's got a positive bump in here, and then the Pacific North American is very negative here, and then we do get a nice ridge on the west coast where it goes to near neutral. So these are a little more amplified on GFS than the European, but it gives you the same general idea. All right, let's take a look at our sensible weather pattern. So the next event coming up here is the one on Wednesday, Thursday. Now everyone's talking about Friday, Saturday, but we have to talk about this one first, and I'll tell you why. We have to figure out how much cold air comes behind this system. So this is Wednesday night. Okay, there's our low over Ohio. Nice snowstorm here for Iowa, Minnesota, Wisconsin, Michigan, and then this is all, of course, rain and warm temperatures here. But notice this enormous Arctic high here, 1044 millibars. Okay, that's a monster. And there's a lot of cold air behind it. It gets even stronger here, almost approaching 1050 millibars. Now this is Thursday morning, yeah, and you can see the lows over near close to Albany, all northern New England, Montreal, Toronto, northern Vermont, New Hampshire. They're all getting a monster snowstorm here. A lot of rain in southern New England, mid-Atlantic states here, but here comes the high driving the cold air in. You see these north winds? Look at these north winds driving that cold air in, and that's important. Because what happens is that sets up the next event for Friday night and Saturday. So this here is the surface map. Now this is Friday afternoon. That same big high, you can see it is now here. Look at this, 1045, closing in on Montreal, and we still have north winds affecting the cold air all the way into down the coast here. And there's our next system, a low pressure area. So the snow is breaking out like this, trying to push up against the cold air. So that's what begins to happen on Friday afternoon. Now, on Saturday, let me go to here. This is what the GFS model is showing here at midday and the 18Z. You can see it's got significant snow and ice in Virginia, maybe northern North Carolina, eastern portions of West Virginia, all of Maryland, and we still look at this Arctic high. It's still over Montreal. So that if that's true, you're still getting a north wind here, which means that all the precipitation has to be frozen. Once this high gets off the coast, the winds turn around easterly direction, the cold air will fall apart, but not if the high is still over Montreal. And there's our surface low there. You can see it just west of Chicago. So the main low is west of Chicago, and we're getting precipitation in Virginia, Maryland, West Virginia, and North Carolina. So this is a big system. Now this is all warm air in here. Okay, so that's what happens. And then eventually, of course, the low does track from Chicago up to Toronto, right over Detroit, it looks like, from here. You can see that. And of course, that drags the warm front northward into Pennsylvania and then New York State. And eventually, the warm air actually gets into central or southern New York State and southern New England. You can see that later on. So, but again, that doesn't mean that before that happens, we could see significant snow and ice in large portions of Virginia and the Shenandoah Valley, and Maryland, Pennsylvania, Delaware, New Jersey, and what have you. Now, this is how the GFS model is showing it here at midday. If you break it down, so it's got snow into Richmond about 4 a.m. Saturday. You can see it approaching Franklin as well. You got snow and ice here early Saturday morning over Roanoke and the Shenandoah Valley. Lynchburg is going over to heavy ice. Moderate snow in the central Shenandoah Valley. The snow has not reached DC yet. Saturday 4 a.m. Now let's talk about here. 10 a.m. on Saturday. You can see that the snow is pushed up into New York City, just about to get there. It's in Philly. This is all heavy snow here in Washington, Baltimore, up into western Pennsylvania. Look at this ice, heavy sleet over most of Virginia, except for the southern areas, and then freezing rain in southwest Virginia. All right, that's what the GFS is showing. And then this is later on in the afternoon. You can see, again, 1 o'clock on Saturday. Right here you can see that, and now most of the precipitation has come to rain over central and southern Virginia. The ice is gone, but you can see heavy ice in DC, in northern Virginia, the northern Piedmont, the Shenandoah Valley, and then heavy snow in northern Delaware, Baltimore, Philly, New Jersey, much of Pennsylvania, and that continues even by 4 o'clock on Saturday. It's still snowing heavily in Baltimore and Philly and New York, pushing into Connecticut, State College, Scranton, Binghamton, what have you. It's gone over to all rain in Washington, D.C., and most of southern Maryland and most of Virginia. Now, that's what the GFS was showing. The European is showing something a little different. It has the precipitation coming in differently here. You can see the European comes in, has the precipitation not getting into central southern Virginia at all. It goes up the Shenandoah Valley. So you can see that Richmond only gets a little bit of snow and ice, and then it quickly goes over to rain in central Virginia. Now, the Shenandoah Valley gets heavy ice out of this, and so does Pennsylvania get heavy snowstorm. That's fine. But it's for eastern Virginia, as you can see, in central Virginia and southern Virginia, it's essentially a pretty big rainstorm, really, when you think about it, for all of this area. Again, some snow and ice in D.C. Quickly turns over. Baltimore, the suburbs of D.C. would have a significant ice storm here, potentially. Leesburg, Ashburn, Germantown, Hagerstown, Frederick, and the entire Shenandoah Valley, even on the European. Now, obviously, we don't know which solution is correct, but the European ensemble, if we look at that, this is, again, the European ensemble. We can see that the rain snow line, this is Saturday morning, okay, 7 a.m. So this here is the rain snow line. You can see it like this. So everyone here in Virginia is still getting snow. And that's not what the regular European model is showing. And then this is 1 o'clock on Saturday, okay, and this is the 0 line here, and the 32-degree line is up across Washington, D.C. So Richmond will be 34 degrees, rain, snow mixed. Still heavy ice and snow in the Shenandoah Valley, D.C., eastern portions of West Virginia, much of western and central Maryland, and so on and so forth. So the European model is showing more cold air than the operational run is. So that's interesting. We're just going to have to wait and see how this plays out, which scenario is going to be correct. And the key to the whole thing is this cold Arctic high and how much cold air is coming down Friday night into Saturday morning. That's the key to the whole thing. Okay, and we won't know that until we know what happens with this storm, the first one. That's what I'm telling you. We don't know about Saturday until we find out what happens on Thursday or Friday. Okay, just got to keep that in mind because that's what sets up the cold air. All right, now longer term, That storm moves off the coast, becomes a big storm in the Gulf of Maine, a really monster storm, as you can see. It goes over to heavy snow in much of maybe New England, maybe to the coast. And big blizzard conditions in Montreal as well, upstate New York, Vermont, and Maine, what have you. Now, this is the 11 to 15 day. I'm presenting it again because this takes us to January 24th, and you can see the very nice looking winter pattern here. As we go further out in time, if you look at the individual frames of the European model, you can see that we have some sort of hint of a positive western base negative NAO. We're getting these high rises over Greenland and mostly over Canada, I should say, in Hudson's Bay, and that implies some sort of negative NAO, not over Greenland, but over northeastern Canada. And that would be very favorable for winter storms on the East Coast. If we look at the temperatures, this is the GFS, and you can see that the 8 to 12 day takes us to January 25. Temperatures are very much below normal, 4, 6, 8 degrees below normal. Now remember, folks, these readings are in centigrade, and so keep that in mind. Fahrenheit's a little colder, and then also these are temperature anomalies. I'm not saying 4 degrees below zero. Okay, these are temperature anomalies. Pay attention. And you can see again at the bottom right here, this is the 8 to 12 day, takes us out to January 28th. So we are really locked in the cold pattern once it comes in. And then if we look at the extended European, the operational European this afternoon has a coastal storm, January 22nd. This is the time frame I'm talking about, sometime between the 22nd and the 25th or 26th. I don't know which one yet. It's too early. It's just looking at the overall pattern and seeing how it develops. We have a large Arctic high over Montreal, a big low off the coast. Is it close enough? I don't know. It's just a possibility right now. Interestingly enough, the European ensemble does show this. Absolutely. Now it's got one for January 26th. Now this is a different system, but again, it's showing something around this time frame. So, that's really all we can say about it. Longer term, if you look at the CFS here, you can see that you can see a very impressive cold pattern after February 4, and then the trough remains very strong February 16th. Now here, what's interesting to note is that the CFS is moving the polar vortex here into Quebec, and that would indicate a serious Arctic outbreak over the eastern United States if that were to happen. That would be interesting. Very interesting if that happened. And you can see what the model is doing. I'm just letting you know. I'm not sure if this is correct, but it's a possibility. And I'll just let you know, look at these temperature anomalies here. And remember that this here now is in Fahrenheit. These are in Fahrenheit. And you can see the light blue and the white color. See this color here? That's 15 to 17 degrees below normal. Look at that. Up in here, that's 20 degrees below normal. That's pretty damn cold for the beginning of February. So we'll see if that actually happens. Like I said, I think it's going that way. And of course, since the MJO and everybody else is going that way, the Indian Ocean dipole is dead, things are looking pretty promising. This is meteorologist DT from Weather Risk. I'll talk to you soon, and see you on the Facebook page and on the Twitter page.